This is Paul Burnett interviewing Dr. George Luxbacher for the Oral History Center's Global Mining and Materials Research Project of the Business Series. And it's February 17th, 2015, and we're here at the Convention Center in downtown Denver, Colorado. So, Dr. Luxbacher, can you tell me a little bit about your background and where you were born and a little bit about your family?
Yes. I was born in Pittsburgh, Pennsylvania, 1951. As a matter of fact, just as a little aside, the other day I was going through some files and I came across the bill my mother got from the hospital the day I was born. So it's just interesting to see that I still had that. But so I was born in 1951 in Pittsburgh. My parents, my dad at the time was a meat packer. He worked for a meat packing plant, and my mother was a housewife. And we lived in Baldwin Borough in the South Hills of Pittsburgh. So my dad, when I was younger, the meatpacking plant my dad worked at closed, and he wound up he was off of work for a few years and did some other things, and then wound up in the steel mills. So I have a blue-collar background, and I'm one of 5 children. I was the first to go to college. Between my dad's and my mother's brothers and sisters, I believe I was probably the first to go to college. So real blue-collar background.
Right. And in coal country, too.
In coal country, too. Although in Pittsburgh, while we were in coal country, we weren't really in coal country. I mean, you're in a rural area, and I really didn't know a whole lot about coal mining at the time, other than the fact that we were close to the U.S. Bureau of Mines Brewston Research Center. And as kids, you always do these field trips. So we went on field trip to Brewston, and I still remember this. This is burned into my mind. They would do a methane ignition in the mine. And they'd have a mine car in there, and they'd ignite the mine and blow a mine car out the portal. And so you'd have all these kids there that came for a field trip, and they'd set this off, and the mine car would come blowing out the entry. And it's just burned into my mind. I just remember that day vividly.
You thought that was pretty neat.
I thought that was pretty neat. But I really didn't give a whole lot of thought to being in the mining business. My dad's father, so my grandfather, who I never knew, he had died of black lung before I was, well before I was born. But he had been a coal miner, and he and all his brothers had been in the mines. I think one of his brothers was killed in a mine explosion, another one in an accident within the mine. So but it was a strong mining family. And my grandfather was a mine foreman, possibly a mine superintendent. You never really get an answer out of my dad, because my dad didn't really remember too much of this. But my dad did remember going underground with my grandfather on weekends to start pumps and things like that. So I remember my grandfather going underground with his tie on and everything, the more formal management role, going underground on weekends to start pumps and things like that. But I really didn't give a whole lot of thought. And my other grandfather worked in the mines too. My mother's family was immigrated from Croatia. And my grandfather on my mother's side, one of the first things he did when he came to the United States was work in mines. So he had a mining background, and then he left the mines and became a shoemaker. But so both my grandfathers worked in the mines. One grandfather extensively, the other grandfather just for a short period of time. And as a matter of fact, where my mother, one of the houses my mother grew up in was very close to where the Bureau of Mines Brewston Research Facility was, right down the road from that. So when I decided I wanted to go to college, I was a path predetermined. I really wanted to do that. And I started out at Penn State in electrical engineering, simply because I was an amateur radio operator and I was interested in electronics and things like that. And so I went to Penn State and I started out in electrical engineering, and quickly realized that it was a numbers game. It's like most of these fields, so many kids want to be electrical engineers that the whole system is geared to getting rid of people as quickly as possible, weeding out so you can narrow it down to those that want to go forward. And being first generation going to college, I just didn't feel comfortable in that environment. So I thought, I need to find a different major. And I moved over to geology. So I went over to from the College of Engineering at Penn State to the College of Earth and Mineral Sciences, and I went into the geology curriculum to work on a BS in geology. And I had an advisor over there. So I did that for a year, and I had an advisor over there, and I still remember I went into him one day to talk about courses and everything, and he said, "You have a lot of potential, but there's no jobs for bachelors in geology." He said, "So you might as well already plan on the fact that you're going to have to get a master's and probably a doctorate." And he says his specialty was plant paleontology, and he said, "I think you'd make a good plant paleontologist." Mm-hmm. And I'm sitting there, I'm first generation, I'm happy I'm just in college. Right. And here I have a guy telling me already that I have to get a master's and doctorate, which to me this was well beyond anything I could ever dream I was going to do. So my answer to that was, well, I'm going to go find another major. So I debated what I wanted to do, and I was over at the College of Earth and Mineral Sciences. They had a mining engineering curriculum. So I took advantage. I went over and I talked to Joe Hunt, who was at the department, and Tom Falke, Dr. Falke, who's actually here at this conference. Mm-hmm. And I made a decision that this mining engineering thing looks pretty interesting. I'd go back to my grandfather's roots, and I'll become a mining engineer. So that's really what got me in the path. So it was a sort of convoluted path to get there. Mm-hmm. What's interesting, just as an aside, is I have a son who's a mining engineer, a daughter-in-law that's a mining engineer. My son, I'd never dreamed he was going to be a mining engineer, but he grew up listening to me talk to my friends, and when time came for him to decide what he wanted to do in college, it was predetermined to him. He was going to be a mining engineer. This is the path he wanted. I got there a little bit different path.
Right. And you must have had an aptitude for mathematics in high school. You'd already...
Yes, I'd taken some advanced classes in calculus and all that kind of stuff in high school. So I really wanted to be an engineer. Growing up, my father, since I was a blue-collar background, basically, I didn't know a whole lot of people that had been to college. Just wasn't the kind of people, all my uncles and everybody, and the people that my dad met. So I really didn't have any role models per se. Mm-hmm. And other than the fact that I met a lot of engineers through amateur radio. So that's why I went that direction to start.
This is ham radio?
Ham radio, yes.
Okay.
Yeah.
And this was big at that time. I mean, my uncle is still a big ham radio enthusiast.
It was big in that time. I'm not so much these days, simply because I have so many diverse interests anymore. Mm-hmm. But back then that was a major part of my life, and all my friends were ham radio operators, and it's what we did.
Did you have, because it was kind of the internet of its day?
It was the internet of its day, yes. Yeah. And I loved code, Morse code, and that's mostly what I did was Morse code. Mm-hmm. But yes, it was the internet of its day. Talked to people all over. I still have boxes and boxes of what are called QSL cards, where you confirm contact, and so you mail these back and forth to each other. So I have boxes and boxes of these things from that era.
And you also maintained your equipment. Is that also part of it? You had to know to recap the...
You had to have more knowledge. Today, everything's solid state. You just go buy something. Back then, you had to have a little bit more engagement with your equipment. Yes. Right. So, and that's why I had an interest in electronics and starting out in electrical engineering. Yeah. The interesting thing about going into a mining curriculum is, and this is what I really like about a mining curriculum, is you get exposure to all elements. So I took classes in electrical engineering, I took classes in geology, I took classes, so you had the basic engineering classes, but we had more surveying than civil engineers had. So because underground surveying is a very complicated deal. So we had more surveying than the civils. We got exposure to electrical, all those different fields. And it's just it's a great curriculum.
It's a very hands-on, very practical.
Yes.
And it's a little early in the interview to get philosophical, but one of the things that people have been talking about in education is there's this technological enthusiasm, but what passes for technological enthusiasm is dumping a laptop in a child's hands and expecting them to sort of figure stuff out. But this is a different kind of...
This is a different kind of engineering, different kind of engagement. And that's part of the problem today with mining. Kids today, they grow up with video games and everything, and they want to be, to them, they don't want to get their hands dirty. It's a different kind of view of engineering. And whereas I was thrilled to go underground. I was thrilled to get the hands-on, the practical aspects of this, to actually go out and be a ventilation engineer and take what I learned in school and actually apply that at the mine level and things like that. Today, kids come into this. I think we get kids that have a background in mining, family background, and they understand what they're getting into, but there are other kids that just want to do the software part and things like that, and they just don't quite grasp it.
Yeah, and that's part. It's not so much their fault. It's that we've black boxed computing. We've black boxed technology. So you just sort of use the apps, but you don't understand the intimacy of the electronics and the machines and how they work and the math involved.
And part of this, as I mentioned earlier, before we started the interview, I'm interested in history, so I've been going back and looking at AIME history. So I look at the engineers of the early era. AIME was founded in 1871, so you're looking at 1871 to 1900 here, and you look at what these guys had to do in terms of hands-on and practicality, and all that still carries through to the curriculum today. Very hands-on curriculum.
Yeah.
So I guess I'll go back to I'll go back to the mining engineering at Penn State. So I went into mining engineering at Penn State, and it actually was very. I immediately got a summer job with Consol, and it was interesting. I was paid more money on my first summer job than my dad was making working at the steel mill. So here I am, and I'm working UMWA, worked at the Oakmont mine as a wireman. As a laid rail and hung wire, because you had trolley, and this was an old mine. We were still running DC equipment and everything else, so it was an old mine. And so I hung wire. We drilled holes and hung wire, and then I laid rail. And I worked on Saturdays. I worked on any time they give me, I'd take it. But I made more money working as a summer guy in the mines than my dad was making working at the steel mill. So.
And when you said UMWA, you were working union.
Union, yes, it was a union operation. So.
Right.
So I started out, and I worked at Oakmont one summer and went back to school, and then the next summer I worked company, salaried instead of union, and I did time studies at different mines. So it gave me an opportunity to get a little bit more engaged in a different aspect of it.
It's so interesting. I spoke with Dr. Falke yesterday, and he talked about the time studies that were going on at that time. And I asked him, and I said, is this kind of like Frederick Winslow Taylor time motion studies? And he said, yeah, kind of. And so I guess the question in my mind is, this is in the late 60s?
No, this is, I started at Penn State. I graduated high school in 1969, so I started at Penn State then, so I would have worked union, UMWA probably in 71, and then time studies in 72.
Yeah.
So in that era right there. And Penn State had a big deal. Dr. Falke and everybody had a mining is a very cyclic thing. It's not a production process where things just roll off the production line. So especially underground mining, you come in, you mine, you got to do roof support, you have to haul and everything. So you have all these unit processes going on. And there was a big thrust at that time to model some of these things and doing modeling and everything. And there was a lot of interest in how you improve efficiency. Just for example, shuttle cars, which hauled the coal from the continuous miner to the loadout. I was working for Pittsburgh Coal Company, actually is where I started working for summers, and Pittsburgh Coal Company they didn't have belts. We used rail haulage back then, so it was still rail haulage. And just where the shuttle car tie point would have an impact on the time it took the shuttle car to run from the continuous miner back to the loadout. So you do time studies, and you do that's a loading dock next door.
See.
But so they do time studies, and so we were doing time studies on the efficiency and all that kind of stuff to see how we can improve productivity. So even as a summer Consol, like to put summer interns into that kind of work, because it gave you a real opportunity to learn how the process really worked underground.
Yeah. I guess what's fascinating is that time motion studies in industry, that's the 1910, 1915
Correct.
or so.
Yes.
And this is now 1972, 3.
Yes.
So there's this tremendous. What accounts for that lag? Is it because the processes are difficult to, because it's not a continuous process industry?
I wouldn't say. Well, let me point out that people were doing time and motion studies during that period of time. It wasn't like the industry didn't didn't do that, but I think there was more of a focus on it toward the 70s on an attempt to try to improve productivity.
Yeah.
And I think there was really a focus on declining productivity at that point in time and trying to get the productivity back up on a tons per man basis.
Yeah.
And so Penn State was doing a lot of work at that time on simulators so they could simulate the process. And
operations research.
Operations research, yes. Under an operations research mode, that's what they were doing. And a lot of the companies were going back and focusing on this too. So that's when I actually went to work, and we'll get to that a little bit later on, when I went to work for Island Creek, they actually had a very strong industrial engineering group that did nothing but time studies and things like that. So it just was, it's a component part of the industry. The thing you have to remember is mining's different than everything else because your geologic conditions change every day. So it isn't like you come to a room and your ceiling's the same and the walls are the same. It's a continually changing environment, and you adapt to handle that changing environment, and you have to adapt your processes too.
Right.
And so you can continually, and this mine's different than that mine. They may use the same equipment and everything, but geologic conditions, floor conditions may be different, and so you can always tweak the system.
Right, right. I mean, this is the fascinating thing about the mining industry, and I'm going to be talking with a number of other folks as well about different aspects of this, but the tremendous unpredictability of something that's being done by a very large technical systems, social and technical systems.
Yes. We would like to argue that today we have a little bit more knowledge because we've improved on our predictability, just simply because we continue to advance. We understand exploration and things like that a lot better. But back then we used to call it exploration by continuous miner. So you basically mined and your conditions changed, and yeah, you had a little bit of an idea what a paleo-depositional environment was and how that impacted roof rock and things like that and floor conditions. But you really didn't know a whole lot. You just went in there, you had core hole data that was probably from the 1900s sometime, and you used that for your planning purposes. Quality wasn't necessarily all that critical, so you weren't too worried about sulfur content or anything like that unless you were mining met coals. And so you really didn't do a whole lot of predicting ahead of time. So that's actually when I first got started back in the 70s, that's when there was really starting to get a thrust toward that.
And I imagine, is labor also a part of it? Because labor's agreements, and I do not know this at all, but I'm kind of guessing here, that starting in the 60s, labor's pay increases were key to productivity. To some extent. You're talking United Mine Workers here. United Mine Workers is a little bit different than most other unions. Very militant union, but for example, later in life, I'm dealing with other unions. I'm dealing with chemical unions a little bit, for example, and I've seen contracts that are written that says a guy can only walk at you can only force a guy to walk a half a mile an hour or something like that. So it's even specified in the contract. You don't have those kind of things in a UMWA contract. And I truly think the UMWA is a little bit more of a partnership with industry, but they were still a militant union. That was about the time that different things happen within the unions too. Yes, that's right.
Yeah, it's a very, very interesting period of time.
Yeah, yeah. But I guess going back to your education, so
so I finished my my bachelor's and interviewed at a number of coal companies. I actually flew out to visit AEP, and it was the first time in my life I'd been on an airplane. So again, the blue-collar background, and back when people didn't fly quite as much, so it was interesting. But I interviewed, I don't know, 4 or 5 different jobs, got job offers from everybody I interviewed, and then decided that I had worked for Pittsburgh Coal Company, which is a subsidiary of Consolidation Coal Company, as an undergrad, so I worked union for them and worked salaried, and I decided to go back to work for them. It was right there in Pittsburgh, and an area I was familiar with, and just decided to stay there. So I joined Pittsburgh Coal Company and started out in the safety department. So that's my first, that's the direction I went there. Very first job was as a safety engineer and looking at accidents back in that time, and I had actually done a column for Geotimes that talked about this a little bit a few years ago. But back then, the fatality rates is an industry that fatalities were extremely common. And when I worked for Pittsburgh Coal Company, we had 8 or 12 mines within the Pittsburgh Coal Company group. I'd have to actually count them to remember how many. But we had a fatality a month. And so we would investigate fatalities and things like that and accidents. Very different than the industry today. And a lot of that had to do, at that time, we used rail haulage, even section rail haulage, so we had a lot of fatalities with people crushed between cars and things like that. Very different industry today. But so I was a health and safety engineer for a while, and I still remember I was talking to a fellow from Consol last night about we had to clean out file cabinets. We were short of space, and I still remember emptying file cabinets and throwing things away. And we had accident reports from the early 1900s, 1920, 1930, talking about a mining section, and listed the number of languages being spoken on the section. So you had it was hand loading, so you had 15 guys on the section, and there were 12 languages spoken, and the section foreman didn't speak any of those languages. Right. It's just so communication. It was just interesting. It's a shame when I look back on it that we threw that stuff out, but we trashed tons of that stuff. Right. So I was a safety engineer for a while, and then I moved over into division engineering. So I took over a division engineering role for 3 mines. So I handled the underground surveying, planning, mapping, things like that for 3 different mines. So that was I was doing that. And then I was debating what I wanted to do. At that point in time, here was a guy who said he didn't want to be a geologist because I couldn't comprehend the fact I'd go back for an advanced degree. Right. And I had made a decision that this is interesting, I'm enjoying this, but I need more education. So I had started looking at an MBA and applied to Carnegie Mellon and Duquesne and a couple other local universities. And I was about to do an MBA. And while I would continue to work probably, or try to work something out there where I could continue to work. And out of the blue, Bob Stefanko from Penn State called me and said, I have a research project on ventilation. Would you be interested in doing this? And one of the things I had done for Consol is I was a ventilation engineer. So that was when I was in the safety department. That was one of the things I did was mine ventilation. So I had done mine ventilation surveys at probably 8 different mines within Pittsburgh Coal Company, and I'd probably done simulations on the mines and things like that. And which was, I guess I don't want to divert too much, but that was always interesting to do these ventilation surveys, going back into places in the coal mines where nobody had been in 20 or 30 years, but you were trying to figure out where the mine courses, even though you had to walk certain air courses legally, there were places we had to get to try to figure out the mine network that nobody had been in for quite a long time. It was an interesting project. But Bob knew I had been doing some of those things, and so Dr. Stefanko called and asked me to meet with him and talk to him about coming back for graduate school. I had a young family at that point in time. I had a daughter, and I was a little bit worried about funding and all that. And Bob convinced me to come back, be a full-time student for 9 months, and then he put me on as a teaching assistant. So that's what I did. We packed up and moved back to State College to become a grad student, and with no intent on getting a doctorate, just getting a master's. That was just it. I just wanted something more because one of the interesting things, while mining was so hands-on, there were so many rules of thumb, and here I was doing planning, and people were saying, okay, we want to put an air shaft in every 3 miles, so we're going to put the plan in. We're going to put an air shaft in here. And I'm a ventilation engineer. I'm doing simulation, but there were so many people that were focused on the rules of thumb, the old way to do things. Right. And so I said, I'm going to go back to school. I'm going to get an advanced degree and find out what direction I really want to go here and do a little bit more engineering. Right. And so Bob gave me that opportunity, and it was a great opportunity to come back and work on my master's. So moved to Penn State, lived in an apartment for 9 months, bought a house, moved into a house there, and worked on my master's. Got my master's in mine ventilation. Penn State was doing some things with their vent simulation, so I got my master's. And I tied that into an actual underground ventilation survey that I did at an underground mine, Vesta 5, as I recall. Former J&L mine, I forget who had it at the time, but so I did an underground ventilation survey, tied that into the Penn State ventilation simulator, and helped complete a whole bunch of different government contract reports we had to do. Finished that, and then Bob says, well, I got research for a doctorate if you want to do a doctorate. So without even really intending to, I wound up staying at Penn State to get my doctorate.
And I guess the other piece of this is that you mentioned government contracts, that there's a demand for safety research.
Yes.
Because in the 1970s, and there's OSHA, and I guess NIOSH becomes a...
Well, as I mentioned, we had a lot of fatalities in the industry. When I worked at Pittsburgh Coal, the fact that we knew we were going to probably have a fatality every month at that point in time in industry was you know, it was not admirable for the industry. But you had the Bureau of Mines, and Bureau of Mines that's one of the worst things that happened to this industry when the Bureau of Mines went away. But you had the Bureau of Mines funding university research on a slew of different things. At that time, you had work being done on automated bolting, some concepts that industry had tried, but here's the government funding this research on trying to improve worker health and safety, trying to remove the worker from that hazardous environment, move him back. And so that's basically where a lot of the funding. I was blessed that I was there at that time. And I could receive Bureau of Mine funding for this. So that was the ventilation work. And then they continued to fund the work. I did my doctorate on trailing cable protection. And that was under a Bureau of Mines contract as well.
And did you find that, did this research alter the rules of thumb in some cases? Did you find surprises like that?
Well, it's when you never alter the rules of thumb. You got the old guys out there; they're still rules of thumb. But I can say that I felt that both my master's and my doctorate helped to advance the practice of engineering. So to that extent, I felt we actually brought something to the table. I don't think I would have picked mine electrical systems to do my doctorate on, even though I was a ham radio operator and everything. I had gotten away from that. I was more interested in other areas, but that's where the funding was. And Bureau of Mines had a research project, so I wound up doing my doctorate on mine electrical systems. During that time, we also, Penn State had a small contract on going back and re-examining the Sunshine Mine Fire, which was interesting. They gave 3 universities a small contract to look at that. Michigan Tech, Rudy Gruer, Colorado School of Mines, and Penn State.
Briefly, can you talk about the Sunshine Mine Fire?
The Sunshine Mine Fire, and again, this is, I think, way back in my mind on all this, but Sunshine Mine Fire was a major hard rock mine fire that occurred. A number of people died, and it was related to smoke migration underground and things like that. So this wasn't even a coal related, this was hard rock out in Idaho, and so there was a lot of litigation over that and things like that, and as to how the smoke propagated and how that cut off people's escape from the mine and things of that nature. So we did Penn State was one of 3 universities to examine that. That was a very interesting project. So these were the little things that came up while I was at Penn State that gave me an opportunity to do some other things. That was really an interesting project.
And so, so you complete your PhD in which year?
Completed my master's. Let's see. I graduated in 1973, and I graduated a term early because I had been in electrical engineering. I had been in geology. I had so many credits that I was well ahead of the curve. So I graduated early. So I graduated in winter 73. Went back to school in 75. Finished my master's in 77. And then finished my PhD up in 1980. So in 1980, I graduated with a PhD and tried to figure out what I wanted to do. Had some overtures from a couple universities. The faculty situation back then was not as dire as it is today. Today it's a big issue. Back then it wasn't quite, but I had an opportunity. I could have went and I could have taught. And at that point in time, I had basically put financial gain on hold for a number of years. I had a growing family at that point in time. I had 2 children, and I decided, okay, it's time to make some money here. So it was interesting. Consol called me back. They wanted me to go to work for their research group. Doug Dahl, who is a good friend, wanted me to come back to work for them. And Hilmar von Schonfeldt, who I'd worked with at Consol, wanted me to come to Oxy. And so I had a couple universities, I had a couple other options. And I really felt at that point in time I wanted to get into some type of a research mode rather than just go back to engineering. Here I am with a doctorate. It's sort of hard to go back and be an engineer for a coal company. So I wanted to get into the research mode. So Occidental, since I had worked for Consol, I knew Consol. It was just interesting. Here I got this opportunity from Occidental, who owned Island Creek, to go a different direction, different mines, different fields. I just thought it would be intriguing. So I elected to go that route. And I went to work for Occidental. They put me, Occidental was doing mining research. Occidental at the time, they had bought a company called Garrett Research, and Garrett Research morphed into Occidental Research Corporation. They were doing the work on oil shale out in Colorado. They were doing work on coal water mixtures, coal oil mixtures. They had a slew of different projects underway, and they also did the mining research for Island Creek Coal Company that Occidental owned. So I went to work for Occidental Research in Island Creek's West Kentucky division. So that's what I did. I wound up in Madisonville, Kentucky.
And this is purely extraction research?
Purely mining systems.
Right.
Yes, extraction, but mining systems, ground control, and things of that nature. So I went out to West Kentucky and hit the ground there. I'm the only person there from Occidental. It's a coal company. They're trying to produce coal. So I had to fit myself into their culture and things like that, which was I had a vast enough background in operations that I could easily step into that. Yeah. But I did ground control research. They were doing conventional mining there yet, so they were doing continuous mining and some conventional mining. When I had worked for Consol, I had seen both. I guess I forgot to mention, when I was with Consol, I actually got my miners papers, my machine runners papers, and my shot firers papers. So I had an opportunity at Consol to run underground equipment when I was working UMWA and salaried, and also had the opportunity to do some blasting and things like that. So I had my certifications there. So go ahead.
Oh, just a brief question about conventional versus continuous operations and how they're different.
Continuous is not continuous, but they define it as continuous. Conventional is a little bit different. You come in, you have the coal face, you undercut it with a coal cutter. You come in, you drill holes, you shoot it down, then you come in with a loader and you load it out. Right. So it's basically a drill blast for underground coal. Mm-hmm. Continuous simply means that you have a cutting head with cutter bits on it, so you cut through it. Mm-hmm. And so to some extent you're continuous. Unfortunately, you have to get the coal from your miner back to a belt head or something like that. Mm-hmm. So over the years, different things have been tried. Continuous haulage to run from the miner back to your haulage, be it belt or be it rail going out of the mine. They've tried different things, but so continuous is a misnomer. Mm-hmm. You actually operate for a fraction of the time that you potentially could operate that equipment.
Right.
But when I went out to West Kentucky, they were still running mines with conventional equipment, and they were still running mines with continuous miners too. So they had both, and they were actually planning for longwall mining. Doing some planning for longwall mining. And so I had the opportunity to do a lot of ground control research out there and work on specifications for longwalls and things of that nature. Mm. Very interesting, very different from the Pittsburgh seam, where I had worked for Consol and done a lot of work in the Pittsburgh seam. I'm out in West Kentucky in the number 9 and number 11 seams, and just very different conditions and things like that, which mm-hmm. is one of the reasons why I went with Occidental, is I wanted a chance to see what Island Creek had in the world versus what Consol had in the world.
And ground control is managing the flow of the coal?
No, ground control is managing roof conditions.
Okay.
So we were very interested.
Literally ground control.
Ground control, yes, the ground control, so you don't have roof falls.
Okay.
And we were doing a lot of planning out there for long walls, and we're trying to size pillars and stuff like that. So I actually put a lot of convergence stations in underground, and would go underground and measure roof convergence and do plots and things like that, trying to morphing all this into some pillar design and things like that. We also, is interesting because we mined in places we had mined the 11 seam, we were mining the number 9 seam underneath, and you tend to get floor heave and things like that if you don't superimpose pillars and do different things. And I had an opportunity to do some ground control related to that, to look at some convergence measurements and things like that. So it was interesting work, but here I was. I had come from I lived in Pittsburgh, moved to State College, university town, and then I moved to Madisonville, Kentucky, a town of 8,000, very small town, dry town, can't get a drink in a restaurant. It's very different, and my spouse at the time was not extremely pleased living. I think it was a little bit of a cultural shock, a little bit different.
That was a bit of a navigation.
Yes, and so Occidental Research's solution to this was to send me for a while down to Keene Mountain, Virginia, where our Virginia operations for Island Creek were, to show me how the research group down there, what they had to contend with in Southwest Virginia, is a little bit different. There was an opportunity that opened up with Island Creek then in Lexington, Kentucky. They advertised for a position for a director of technical services and engineering data and technical services. And so it was an opportunity then to relocate to Lexington. So I actually saw this ad in mining engineering for the position. So here I am working for Occidental at Island Creek's mines, and I open up mining engineering, and here's this ad for Island Creek. So I said, wow. So I apply. So I wound up working for, that's how I moved from Madisonville, Kentucky to Island Creek in Lexington. So I morphed over to the Lexington group.
And what were you doing at Island Creek when you got there?
When I went to Island Creek, it was a newly created position at the time, and we were basically, it handled managing the reserve function, the company reserves and things of that nature. We were just starting to get involved in China then, and Island Creek had a big project, Antibio, in China. And the vice president of engineering, who I was working for when I went there, he spent 80% of his time on the China project. This was a big thrust for Occidental. Dr. Hammer meant a lot. So his focus was on China, and he needed somebody. He was trying to build an organization that could continue some of the other stuff that he should have been doing, but he didn't have the opportunity because he was so involved in China. So I wound up in there and basically managing the technical data associated with the company, the reserve data, reserve reporting for the annual report, SEC filings and things of that nature, although coal reporting is a little bit different than metal and non-metal. There's a lot of vagueness to coal mine classifications and stuff like that for reserves and resources and things of that nature. But I managed that. I managed the technical data associated with the various mines that we had. Actually pulled together probably the first summaries of everything associated with each one of those mining operations. It was an interesting job.
And how do reserve assessments work? Is it more incremental in the sense that as mining continues, they discover, oh, probably we have more?
No, you have especially in coal mining, you have a fairly good idea what you have. That's one of the interesting things I learned when I morphed over and did work in other Occidental subsidiaries, is in the coal company, you live, breathe, and die by your reserves. You know what you own. You know what mineral you control. You know what surface you own. And I was a little bit surprised when I started dealing with a chemical company, and they had no idea what property they owned. Very different. But you know what you have, and you have some type of drilling data, and sometimes it's old drilling data because it's not related to a current mining operation or a mining operation you're planning, so you're not too worried about it. But you can assess whether you have reserves or not, and you can base it on how soon you're going to mine it as to whether it's a reserve or a resource. Is it associated with an active mine? Have you planned to put a mine into it? How closely spaced is your drill hole data and things of that nature? But you have a lot less exploration data in coal than you typically would have in some of these other mines where you're going after metal deposits and things of that nature.
So your data is typically older.
Older data.
Are there questions of translation? Are there different standards, and you have to then?
Oh yes, you have data. Anytime you have data that's been acquired over different periods of time, different interpretations and things like that. At the time I moved to Island Creek, we just started to implement a more rigorous assessment whenever we did any drilling, core drilling or something like that. Geologists would log it. Before then, we just used the driller's logs, and the driller would tell you what he went through, and that's what you used. And instead, we had more of a focus. We had a couple geologists on staff at Island Creek, and we did a little bit more rigorous assessment of what we did. We started to use John Firm's classification system for rock, so and John Firm had a booklet with pictures in, so you could compare your pictures to your core, and then you could. So the whole idea was to try to get consistency, so that you could ultimately put this into a computer database. And if you put something in as a shaly sand or a sandy shale, and you could code it, it was consistent across the whole board. So we were trying to get to that point in time, which is where the industry's driven toward. This is what I was telling you, is it's a lot different today when you do assessments than what you did back then. It's been a tremendous change in the whole system. But so I managed that function, which was an interesting function. From there, let's see, I'm trying to remember what my next job was.
Well, just in the interim, when was Island Creek getting into China? What years were it?
Island Creek. Well, when I went to Island Creek, so I went to Island Creek in 1982, and Island Creek was already starting to do some work in China. Dr. Hammer was looking for oil and gas reserves, oil and gas assets within China. He was renowned for being the only person who could fly his private plane into Russia and all that. So he actually had the same system in China where he could fly his plane into China. And but he was interested in oil and gas reserves, and interested in then helping to develop coal reserves as a trade-off then to get access to oil and gas reserves.
So I know very little about the history of modern China, but I guess the big story is 1978, they start those special economic zones, and that's sort of light manufacturing.
Right.
I know nothing about Western companies' exploration and collaboration with the Chinese state.
This was one of the first endeavors to do this, and I came into this, it had already been going on, so I can't tell you the early history of it, but I can tell you that Island Creek was competing against Consol and several other companies for the opportunity to build a large-scale surface mine in China. So we were heavily involved at the point in time I came. I still remember the VP of engineering used to love to pull out his passport, and he had extra pages, and there were just reams of stamps from all the trips when he went back and forth. It was a major endeavor. We had I had drafts people and a group that reported to me, and several of those people, we were trying to find people to babysit drill rigs in China. I sent my draftsmen over to China to babysit drill rigs because we needed people over there to do that. So it was a major undertaking for the company at that point in time.
And so this would have been, I mean, there were Chinese mining I don't know if they're companies, but they're...
Well, we were working with CNCDC, China National Coal Development Corporation, and we had we had delegations from CNCDC that worked with us on the planning on this and everything. So we had delegations of Chinese that were there in Lexington, and they had co-teams and a team that matched the Chinese team, and they would meet and plan and things like that. I basically kept out of that. I was dealing with the U.S. stuff while my boss was dealing with the China stuff, other than the fact that I was also at the time putting together some of an early computer system to do some of the modeling, reserve calculations, and things like that. So part of that was because we had told the Chinese we had all these capabilities. In truth, we didn't have those capabilities. And so we had to create those capabilities. So we had, it was IBM Series 1 computer. I can still remember this. And we were trying to use an IBM Series 1, and we went and we bought a CalComp plotter, a huge belt bed plotter, and we were trying to do all these things to show the Chinese we could do all this stuff. It was an interesting time.
So that initial spur of globalization actually inspired the technological development.
At least for us.
We need to show that we have some value added.
Yes. Matter of fact, I was looking back through the list of papers I've done, and I did a couple papers early on about this, about how we did our mine planning and things like that. Because as we did that thrust for China, then later on that morphed into computerized mine planning for our underground and surface operations. Although Island Creek was primarily an underground mining company. We had a couple large-scale surface mines, but primarily they were run by contractors. So I always thought it was interesting that here we were selling the Chinese on our capability to run large-scale surface mines, and as a company we had no large-scale surface mines. We had some people that had experience, but we really didn't have the capability.
Market the capacity and then develop the capacity.
Yes, and that was what was being done there. So it was interesting. So at the time we had all these Chinese there too, when we were trying to do work related to the regular stuff. At the same time, we were trying to do work related to China.
And the Series 1, is that a mainframe or a mini?
Oh, that was a mini computer, IBM Series 1 mini computer. And then we morphed from the, Occidental, their IT group had tied these into their mainframe, the IBM 370 mainframe and all of this. So they used these Series 1s as little mini computers that then interfaced with the main computer. And I still remember we had our own spreadsheet that mimicked an Excel spreadsheet or a Lotus spreadsheet that was on the IBM Series 1 and all this. And they used the huge floppy disks and all that kind of stuff. So I date back to that era. We replaced that. We moved from that to a I got to think of the computer system we went to. We went to a technical computing system, again, a mini computer-based system.
Customized for?
Yeah, I'm trying to think of the name of the company at the time. This is horrible that I can't think
DEC?
of it. Was it a DEC? Yeah, it may have been a DEC. It was another system with the small ones, the small mini computer that we wound up buying the Eagle software off of Morrison Knudsen, and it ran on I think it was a DEC. It ran on the DEC, and so we got ourselves off of Occidental's mainframe system and migrated to our own little mini computers.
And this is early to mid 80s.
This is mid 80s. Yes, mid 80s. We were doing this stuff. So I still remember the very first, when I got to Island Creek, we had not advanced into the computer era other than, running stuff on the mainframe and whatnot. We thought the Series 1 was the cat's meow. Here we got this computer that we can actually put data in, and the Series 1 will then transmit it to the mainframe, and I don't have to have my card decks, I don't have to have my tapes, because my master's and my doctorate, I still have probably somewhere a couple boxes of computer cards of my computer stuff, and I have a couple tapes that were, I thought it was great that I could go from my cards to my tapes, so I still have a couple tapes. And so, but I remember when the very first computer we bought, we had a guy going to China to do volume calculations and things like that, and we bought an Osborne. This big box. It was this huge box. First portable computer, and it had a little tiny screen about this big, and he had to haul this thing back and forth to China. And I remember I then got one of the very first IBM laptops, and this thing, there was no memory on it. Everything ran off of floppies that you had to put into it, and it was you could do so little, and we thought we were we thought we were going
Cutting
great
edge.
guns. We're cutting edge. And we took the CAT simulator. Remember, we got the CAT simulator. We took it from the mainframe. We got it down to the Osborne so we could run equipment. We just really thought we were doing great guns. It's hard to think back to that era, but it's funny. Now, when I boot up my computer, and it takes forever for my computer to boot up, I still remember you'd be doing something on a Series 1, and you'd hit a button, and you go get a cup of coffee and come back, and maybe things were done. Yeah, you get so spoiled on what we have today.
Absolutely. So engineers in the 70s would have had to be running their own they'd be writing their own code? Sure.
Well, there were programs available out there, but you
Okay.
could write your own code too. For example, at Penn State, like I say, we were doing a whole bunch of operations research stuff, and that was all being run on the mainframe.
Okay.
And our vent simulator was run on the mainframe. When I worked for Consol and I did ventilation work and ventilation simulation, Consol had an early vent simulator on there, and I had an interface where I could develop a deck, and then it would be run on the mainframe. So everything was done on the mainframe.
Yeah.
I took a course in Fortran programming. I thought I was a fairly good Fortran programmer.
Yeah.
For both my master's and my doctorate, I wrote code and did some programs.
Right.
And so I was perfectly capable of doing that. Could I do that today in BASIC or C++? No. My children can.
Right.
But I've never morphed. I just don't have the need to write code in what I've been doing the last few years.
When's that cutoff or trade-off, I guess, when you are an expert in, you're able to get close to the machine, as it were, and then at a certain point you're handing it off to someone called an IT expert. When does that happen for you?
For me, it happened toward the tail end of the '80s. I just stopped doing that kind of stuff.
Right.
And I was lucky when I went to work for Occidental, and then we started doing this China stuff and everything. We actually had a technical computing group that operated out of Tulsa. Andy Bouillot ran the technical computing group, and so we had a group of people and that we could work with on technical computing. At the time, Occidental had a company called Occidental Minerals, and they were doing a lot of exploration in the West on minerals, and we had opened up the Candelaria gold and silver mine in Nevada. And with Candelaria, the technical computing guys then had done a bunch of modeling and things like that, and kriging and things, so they were developing programs for that kind of stuff. We had the Florida phosphates, because Occidental Chemical ran phosphates, and that was mining, so they were supporting the phosphate mining in Florida, and they were supporting Island Creek Coal Company too. So suddenly, as we got into China, they started to work with us on these different things. So we had the capability then of a trained IT group that was dedicated toward mining for IT support.
Right.
So that helped a lot in developing software and things like that.
Right.
Up until that, we were doing a lot of this stuff on our own.
Right. That's fascinating.